Gulhane and I feel privileged to welcome you all on behalf of GHRCE College of Engineering to the track session on Cloud Computing and Networks on 2nd PhD Colloquiat 2016. We are honored to have with us Dr. Bhaskaran Raman sir to this colloquia as an expert. We welcome you, sir. Dr. Bhaskaran Raman sir obtained his PhD degree in Computer Science in 2002 from the University of California. In the year of 1997 to 1999, he completed his Master of Science in Computer Science from the University of California. He received his BTech degree in Computer Science and Engineering from the Indian Institute of Technology, Madras. In the year of 2012 to 2013, Dr. Raman sir was part of the Airtights network in research and development team. He worked as a researcher in Microsoft Researcher India and in Alcatel-Lucent Bell Labs, Bangalore, India. Currently, he is the professor in the Department of Computer Science and Engineering at the Indian Institute of Technology, Bombay, India. His research topic belongs to computer networks, wireless and mobile networks, protocol design and evaluation, wireless measurement studies, computing and communication systems, system building and protocol design for embedded sensor applications. We are glad to have you, sir, on the PhD Colloquia 2016. Now I invite PhD scholar Veena Gulhane ma'am for the pre-submission seminar.
Hello. Good afternoon, everyone. I am Ms. Veena Gulhane, presenting my PhD pre-submission seminar on the research topic exploring efficient adaptive reprogramming by optimized multi-hop code generation in ad hoc wireless network under the guidance of Dr. L.G. Malik, who is Associate Professor in Government Engineering College, Nagpur. And the research center is the Computer Science and Engineering Department of GHRCE College of Engineering. See, I have delivered total 7 progress seminars so far and published total 9 papers among 4 international journals and 5 international conferences, which was based on this research work. This presentation is mainly focused on the rationale of study, related work, problem definition, proposed approach and methodology, evaluation approach, experimental setup and assumptions, simulation results, system behavior and empirical results, performance evaluation, relative analysis and findings, limitations and a future research scope, conclusion, publications and references, etc. The rationale, as we all know that every computation environment needs some updations or configurations. So as far as wireless sensor network has been concerned, so normally we deploy the sensors for performing a particular task in a field, but before deployment normally we set a particular software, or we can say that we configure that node for doing a particular task. But as time goes by, it is necessary to change some configuration. That configuring the network or configuring the node many times after the initial setup, that particular process is called as an reconfiguration, or it is called as an reprogramming concepts. So normally reprogramming concept provides the facility to update the software which has been already installed in a node, or if there is any bug, then you can debug it or set some parameters as per the new requirements. So these are the various things that can be done through the reprogramming. And as that nodes are not accessible once you deploy it, so manual intervention is not possible. That's why reprogramming is necessary, which is possible through an over-the-air updations in the node. So normally the network reprogramming is having 2 different mechanisms. The first one is code propagation method and second one is installation method. So code propagation method is the main module of an reprogramming. In that, normally any user program read the binary code, or you can say a code image from the host machine and forward it towards the node which you want to reprogram. And the second is the installation method. So whatever image has been received by any node, it can be switched on the new program. That particular microcontroller of any sensor node which is switched on new program, and the process of rebooting is carried out at the installation method. We have analyzed and evaluated the various architectures which has already been designed for the reprogramming purpose. There are finite number of architectures, and these are the sum of dissemination protocols that are more famous, like MNP, then deluge, E3NP, incremental, aqueduct, and the tiny qubits. These all are the dissemination protocols. We have analyzed the different design factors and properties that normally considered while designing any reprogramming protocol. So that designing parameters are the encoding decoding process, then whether it support a single hop or multi-hop, what is the MAC protocol which can be support, then whether it is sending a complete image or it can support a pipelining for the fast propagation, whether it supports the scope selection, whether there is idle listening or adaptive sleeping, provide the environment like homogeneous or heterogeneous, then whether it is allowing some security function, on what basis or platform the implementation is carried out, what is the simulation support and the programming language. So after analyzing all these parameters, we have chosen some of the design factors for the proposed architecture. So proposed architecture design factors are like it is an code dissemination protocol which use the difference-based method rather than the complete program dissemination. We support a multi-hop. So probably all the previous architectures, they work on CSMA as a MAC protocol, because the TinyOS support CSMA. We are trying to replace by a TMAC, then pipelining and segmentation, then selection support, adaptive sleeping, heterogeneous, security. So these are the design factors for the proposed architectures. So after analyzing, we have find that why there is a need to design the new architecture. So there are some of the common problems in the existing protocols that are that idle listening is there, because each and every protocol, previous one that use the CSMA, hence it consumes a lot of energy that must be minimized as much as possible. There should be support of an heterogeneous environment. There must be a selection support. The reprogramming should be attribute based. There must be a root repairing and recovery, and program code must be delivered entirely whatever the location of that particular node it is deployed. So these are the various problems that need to take in considerations. So for the development of new protocol, normally we have put the name S2 torrent, and this S2 torrent has been designed on the base of deluge. We have chosen the deluge. Now why we have chosen the deluge? Because it is a most commonly available over the air programming protocol as a dissemination. It supports multi-hop and dynamic dissemination. Then it uses the incremental upgrade. So we have tried to overcome the limitations of an existing deluge and try to put forward a new protocol which is more robust and efficient adaptive reprogramming framework, which enhance the capability of existing deluge. As far as deluge is concerned, the various research gaps are like the algorithm used in deluge is uncontrollable, like it is not that much energy efficient. Then there is idle listening takes place. Individual mode is reprogrammed up to n-1 times. There is a problem of hidden terminal. and there is no feedback, it means at any time we cannot get the idea what exactly is happening at the field, what is the status of an reprogramming. So normally we need some feedback. So these are some of the problems that we had taken care in the design protocol. So according to research gaps and the various issues of a sensor network, the resource constraint of a sensor network, we have designed and finalized the various objectives. So first is to survey about the conventional reprogramming agent of WSN, investigate performance and efficiency of existing architecture deluge, then suggest some modification in the existing architecture, propose new reprogramming framework and create a novel reprogramming agent, and investigate the performance and efficiency of proposed protocol in terms of control overhead, while handshaking and advertisement, secure authentication, heterogeneous environment, whether the control flood is there or not, energy efficiency and the reliability of an protocol. We have simulated these protocol by using a network simulator, that is Omnet++. These are the design contributions and the design modules that we have applied in the proposed architecture. First of all, we have designed the architecture, or we have designed the framework of an S2 torrent, then the state diagram on the basis of the design architecture. Then we have tried to design the protocol stack and the various design modules, or you can say the implementation modules, that are the multi-hop support, selection support, TMAC support, secured authentication and the attribute setting. And we have evaluated this result and the behavior of an protocol through the energy consumption, broadcast storm problem and hidden terminal problem, then reprogramming time and the reliability. And at last, we carried out the relative analysis. So this is a proposed architecture, or you can say research design framework. So normally this reprogramming architecture has been carried out in 3 main stages. First stage is encoding, second one is data dissemination, and third stage is decoding and switching a node to a new code. So user program normally reads the code from the host machine. So this reprogramming concept is normally carried out at the administration side. So each and every task is defined at the main station, or you can say a host machine, and according to management interface, it prepares a code, encode that code, and through air it can disseminate towards the field. And when it reaches at each and every node which we want to reprogram, then that particular image or code image can be downloaded, and that node is reboot and start to work on the new task. So it requires a reboot process. So this is an elaborated state diagram on the basis of that existing framework, which shows the detailed functioning and all signal flow. So to be summarized, we can say that this is an S2 torrent. It's a dissemination protocol which is a multi-hop, difference-based pipelining and segmentation, adaptive stripping by applying MAC 802.11 TMAC, selection support and attribute support. So this particular slide shows the protocol stack. So normally reprogramming application is carried out, or it is implemented on the top of TinyOS using an NESC programming language, which allows the definition of various components. So this S2 torrent defines the optimization parameters such as energy, Then application requirements such as reliability and system parameters, like we had tried by varying the density. And as a middleware, we use the TOSIM, NESCT, Omnet++, and we have applied the TMAC IEEE 802.11 at the MAC layer and try to add some security for authentication of the nodes. So this is an evaluation approach. So normally it is very difficult to take a real-time test if we want to test a protocol by using the multiple nodes. So there is certain limitation if you use a real-time. That's why I have chosen to test this protocol on a simulation base. So normally this TinyOS is used as a OS platform in any sensor environment, and the TinyOS programs are designed in NESC. TOSIM is an emulator. If I want to burn the image in the hardware node, then TOSIM takes the image from the TinyOS and then it burns into the TOSIM. But S2Torrent acts like a kernel between OS and node, and as this is in simulation, so I use a simulator Omnet++. I have created a node definition. I have created the n number of nodes. So in this particular protocol, for testing purpose, we have created the 100 nodes that are the definition of an logical nodes. But there is a miscompatibility in TOSIM and Omnet. So that's why we have taken the translator, call it as a NESCT. So NESCT that converts the TinyOS code from NESC to Omnet++ classes. This is an experimental setup or assumptions while simulation. The channel type, definitely it is an wireless channel. The propagation type is two-way ground. The network interface is wireless physical TMAC. The number of nodes in the network are 100. Node arrangement is random. The size of topology in X and Y direction, it is 1800 meter to 900 meter. The protocol type is a flood based dissemination protocol. The simulation area is 1400 meter by 700 meter. Control packet is 8 byte. Data packet is up to 250 bytes. Mobility, we have not considered a mobility for this. The object size is 31. Density is 400 feet per meter square. Packet size is up to, it is 64 byte. And the distance between nodes is varying in between 20 feet to 119. It is just for varying the density. We have checked that protocol behavior. So this is a structure of program image, or we can say a data representation. Normally the object is nothing but the code image which you want to disseminate. So that object is converted in the form of various pages, and each page is divided in the form of number of packets. So we consider here that there are P continuous pages and each page contains n number of packets. So every node broadcasts its object profile and age vector. That object profile consists of a version number V and the largest number page available for the transfer, which can be denoted by the Y, and the contents of page are at version V. So it provides this paging, or if you convert the pages in the object in the form of pages, so normally it provides the facility of an spatial multiplexing, which improves the speed of an reprogramming or dissemination, and pipelining is also possible through the pages. So this is an protocol overview. So normally it has three phases: advertise, request and a broadcast. So it is you can say that it is a three-phase handshake protocol. and which ensures a bidirectional link before transferring a data. So each node periodically advertises metadata. That metadata involves the all information about the new version. Then if we consider the two nodes S and R, if any node, say S, if it is receives the advertisement from the node R, then S responds with its object profile. So that object profile contains the node ID, the group ID, and the what particular version is available with node S. So it will request to R through the profile object, so that R will determines that which particular portion of data is need to be updated, and accordingly it will request for the required code to the neighbors and advertises the availability of needed data including ES2. So nodes receiving that request broadcast the requested data, and hence when any node it gets the new version, then it start to advertise the newly received data in order to propagate further to its neighbors. So as far as the system design has been concerned, so different modules, this is a simulation screen which shows how it supports a multi-hop. So we can, here also we have considered the density of 100 nodes, and definitely the distance between node is 20 feet to 119 that we have considered, and we have tried this simulation for 100 nodes. Then second test was for the 200 nodes, 500 nodes and 700 nodes. So up to 700 node we had tried this particular protocol. So the simulation time is 200 seconds around for 100 nodes that we have monitored. So while selection support, what particular logic we have applied? We have established the connections through at intermediate nodes, just like an aqueduct. So different groups of nodes in the network can be reprogrammed through the scope selection, or we can target any subset of the nodes among the all. So this is the main purpose why selection support is there. But along with selection support, there is always a requirement of an attribute setting. So if I want to choose a particular set of nodes, then what will be the condition, on what basis I will choose that number of nodes. So for that purpose, here I use the attribute setting. So attribute is nothing but the evaluation function. Like for example, we can consider that any physical parameter that can be sensed by the sensor node, you can say that it is an attribute, and along with attribute we normally use the constraint. That constraint is nothing but the comparative function. So there should be a comparative function and there must be a attribute. So for example, if I take the constraint temperature is less than 15, it means that we can define the nodes for reprogramming who give temperature below 15 degrees centigrade. So that particular nodes we can choose for the reprogramming, or we can set the new parameters. So likewise we can set any kind of attribute and choose the set of nodes. This is an simulation log which has been taken on the command prompt while simulation, which normally consists of the initializing network, then advertising of an TinyOS packet, the broadcast page dissemination. So this is a detail about an simulation log. This is segments and pipelining. For the parallel communication, we can use the concept of segments and pipeline. So for disseminating a 31 page object, with a node spacing of 100 feet. We evaluate the deluge as well as S2 torrent. So deluge takes 22.41 seconds for dissemination time, and S2 torrent with selection support it takes 13.01 second, and without selection support it takes 15.96 seconds. So this is an observation. Then we have applied Tmax. So normally in all earlier architectures they use a normal CSMA which is based on the contention base, and there is a problem of an broadcast arm problem and the hidden terminal problem. So to avoid that and to provide the adaptive slipping, we use the Tmax support. Shall I continue or stop, sir? So this is algorithm for an Tmax support. This is a secure authentication. We have provide the security related process like key establishment, encryption, decryption and verification. For that purpose we use Tinky, which is a tiny ECC version. This is a code update process at the node side. Our focus is not much on the code update process. Our main focus is on dissemination protocol. See, we have taken the simulation result and evaluated the protocol on the base of various parameters, and that parameters are the energy consumption, completion time, secure authentication, reliability, broadcast storm problem and hidden terminal problem. For these all parameters we have evaluated that protocol. So under energy consumption there is a network lifetime, the number of living nodes and energy conservation, and for completion time it has been measured in terms of the overall completion time versus object size, then the completion time for the varying density and completion time for node wise. Then memory and time calculation for the secure authentication, reliability in terms of PDR, end-to-end delay, throughput, etc. And for broadcast storm problem and hidden terminal problem, we have considered the advertising time, suppression, hidden terminal problem and average messages per node. So these are the evaluation parameters that we will see one by one. So this is an observation table for network lifetime. So we have taken the observation for the existing deluge which is based on the CSMA, and the proposed one S2 torrent which is based on Tmax with and without selection support. So this is a comparative, or we can say it is a graphical result which shows the number of nodes versus a remaining energy. The second graph shows the number of living nodes, which observation again has been taken for deluge and the S2 torrent. So average number of living nodes at average time T for 100 nodes. They are around 66 in deluge, means 66 living nodes in deluge and 77 living nodes in proposed protocol.
So can I ask you questions in between or at the end?
At the end. As you wish, sir.
I can ask at the end.
Okay, sir. So, as far as this energy conservation, this graph shows the simulation time versus remaining energy. The average remaining energy for CSMA based system is 55.46% and 61.95% for the Tmax base, for the average simulation time of an 205 seconds. So this is an calculation for an percent energy consumed. So the percent energy consumed for CSMA is 98.98%. For TMAC it is 94.39, and for TMAC with a selection support it is 92.42%. In the same way, the average energy consumed, which is sum of percent energy consumed by all the nodes to the number of nodes, it is 0.17 joule in CSMA, 0.16 joule in TMAC, and 0.197 joule in a selection support. Again we have find the residual energy, which is 7.83 for CSMA, 15.54 for the TMAC. The second evaluation parameter was the completion time, which shows the overall completion time versus object size. The object size is 31 pages in this consideration, and we have observed the overall completion time for deluge as well as the S2 torrent, which is, and the next completion time is as per the density. So density is nodes per meter square, it is versus time for completion. This is a time required for the security purpose. So average completion time for key setup, verification and signature verification is 143.85 millijoule, and average energy consumption is 547 milliseconds. This is a RAM use. This shows encoding and decoding time. The next evaluation parameter is broadcast storm and the hidden terminal problem. So normally, because of a data redundancy, contention and collision due to a classic flooding in a high density network, so there are two approaches for the broadcast storm problem: data redundancy and sender redundancy, that always need to be overcome. And the second issue is hidden terminal problem, that need to be prevented. So the first optimization for avoiding the broadcast storm problem is handshaking, that, as we know, already discussed, deluge is 3-phase protocol: advertise, request and data, and you cannot get the current status because there is no feedback. We have added the 4th state, that is a feedback. So with this we get the actual position of an reprogramming, which avoid to reduce the sender redundancy and the data redundancy. So this is the handshaking round, means how much handshaking rounds are required for each node to complete the overall network. So average number of handshaking round required for deluge is 16.31, while 11.36 are required for the S2 torrent. And if you choose a selective approach, then we need only 4.44 rounds in an average. This slide shows an advertisement rate, which again we have considered the advertisement rate for deluge, for S2 torrent and with selection. So the average number of advertisement for deluge, it is 1.99 messages per second and 1.069 messages per second for the S2 torrent. This slide shows the observation and the graph of an suppression, which shows the transmitted request rate. For the varying density we have considered for a 31 page object. So throughout we have used a 31 page object with a different cases. This is how we try to minimize the hidden terminal problem. So we have taken the readings for time versus the number of messages sent. So average number of transmitted requests per second versus percentage number of nodes. Then we come up to the reliability approaches. So in that we have taken the packet delivery ratio, which is normally the total amount of packet received to the total number of packet transmitted. So it is around 89%. Then for reliability, the second one is we have taken the observation for and control overhead. Then what is a particular delay which is required, end-to-end delay. Then throughput. The relative analysis and finding, if you compare the deluge as a term x1, S2 torrent as a x2 and S2 torrent with selection support as a x3. So average number of advertisement, or we can say the number of advertisement by each node to initialize the network, it is 46.27% less in case of an S2 torrent. Now we have compared this result for deluge and the S2 torrent, not for the selection support. And the average completion time for dissemination of an 31 pages, it is 19.53% less. The average number of leaving nodes are 5.67% more. Average delay is 6.04% less. The request rate, or you can say the average number of requests, are 52.06% less. The message rate is 73.51% less. PDR is 17.08% improvement. Packet loss at average simulation of 202.86 seconds is 20.53% less. The overhead packets, or you can say the control packets, are 1.98% less as compared to the deluge. This is an simulation summary and the power consumption for the various operations. So these are the findings that from the relative analysis of an deluge and the proposed dissemination protocol, we can see the impact of an proposed architecture in terms of the various evaluation metrics. So the advertisement rate, that evaluation metrics are advertisement rate, completion time, PDR, packet loss, overhead, dissemination time and average energy consumption. The properties of an protocol are like it is based on the deluge. So deluge is simple. So we can say this is again a simple type of protocol which is density aware. We had tried to take the observation by varying the density, which is scalable, secured, selection support, energy efficient, which improved the MAC, no ideal listening, offer feedback, reliable. The major contribution of this study is that we provide the heterogeneous support for the dissimilar hardware and software and the application role. It also supports the scope selection and secure authentication, efficiency improvement of a protocol, minimize a large number of idle listening, hence it is an energy efficient protocol. We minimize the hidden terminal problem which affects the proper channel utilization. Applied timeout MAC instead of CSMA in majority systems, and the improvement in the reliability. The applications and benefits are: the outcome of this research work will be beneficial in social front for adoption of an wireless sensor network technology, as it will provide more efficient and robust solution by improving the performance of system in the various applications nowadays. It is more economical and practical to reprogram the sensor node rather than deploy a new nodes in the field. Then it has a great ability to obtain the data, and it can work under any situation at any time in any place, which makes it useful in most important fields. The limitations of this study is that the protocol behavior need to be examined on the real test bed. It behaves appropriately up to the scale of 500 nodes only. It is difficult to test the real system developments for large scale scenarios. Hence, current tests are usually small scale, containing only the limited number of nodes. So we have tried this protocol beyond 500 nodes, but it does not give that much result. So this is a limitation that I can say. It can scale up to 500 nodes only. The future research scope, that the research can extend by designing a TMAC enabled nodes, and the protocol behavior can be observed by deploying a real-time sensors and a test bed. To be concluding, we have presented the S2 torrent in this research work. It is an efficient and adaptive image dissemination protocol for reprogramming multi-hop wireless sensor networks to facilitate the adaptive sensor applications. It integrates the new capabilities in the existing framework. It proposes many design principles like adaptive reprogramming for heterogeneous sensor networks, efficiency improvement in terms of the advertisement rate, completion time, PDR, packet loss, overhead, dissemination time, and average energy consumption, robustness to spatially asymmetrical links. The TMAC-based approach, unlike CSMA in most of the existing framework, and it provides the secured authentication and verification, which required 143.85 millijoule and the 547 millisecond respectively. So on this research work, I have published 4 journals, among 2. First one is in the Casmera journal, which is an SCI, volume number 44. The second one is SCI journal, volume number 31. Then one article on the deep literature survey, which was the free journal. And the fourth one is an open access journal. I published 5 international conferences. So one paper is in elsewhere, volume 78. 2 papers in IEEE, one at Korea. The one paper is ACM CPS, which is in process. It has been, which was in Bikaner in 12 to 13 August. And the last paper is again in the international conference at Chennai. The number of workshops that I have attended and conducted during this research span. So I have attended one short course at IIT Kanpur, then PhD coursework, which is compulsory for each and every research scholar here. Then I have attended a 2-month online certification course of an IIT Kanpur, which is on principles of modern CDMA, MIMO, OFDM wireless communication. And on the basis of that knowledge, I have organized a STTP for the PG and the faculties in the college itself, and taken the sessions for latex and the research based some topics. These are some of the references. Thank Thank you. Suggestions, please.
So now you take questions.
Yes, sir.
So I didn't follow what the main idea is. You need to tell.
Main idea.
Yes.
Okay. Sir, if you consider this laptop, this is a computation device. Okay. If I want to use it, okay, what is my initial stage? I'll install an OS, I'll configure it properly.
No. You are doing reprogramming of sensor nodes.
Yeah.
Okay. You are claiming to do more efficient than deluge.
Yeah.
What is the idea? What is the...
See, deluge is an reprogramming architecture which has been already designed.
Right.
It has been used.
Fine.
Okay. I have used RFC of an deluge.
You have used what?
RFC of an deluge. And I implemented a new.
RFC?
Yeah, I had taken the code from the forum, that deluge code, and then I had implemented and modified the modules of an existing deluge.
No. What is the protocol modification you did? Forget the implementation. What is
Yeah.
the protocol modification compared to deluge, which is giving you the performance benefit?
Yeah. Shall I go to this?
Yes.
Sir, look at this slide. If you see a deluge and the proposed architecture, if you compare the design factors, we have taken the design factors from the various, means base possible factors from the various architectures. Like deluge is multi-hop, but it applies CSMA only. We have taken TMAC,
But
then
doesn't TMAC is
timeout MAC,
the-
sensor MAC.
Doesn't it require time synchronization?
Yes, sir.
Doesn't it require time synchronization?
Yeah, it requires a time synchronization,
You
but it is
assume
not
time
like that TDMA and all. TDMA requires more time scheduling. Okay, so that's why it is not preferable in the sensor network. So normally the researchers use the CSMA, and it is inbuilt in the tiny OS
So
itself.
why have you used TMAC then?
Yeah, because there are numerous drawbacks. Because the existing architectures, they are based on the CSMA. Because CSMA itself is the basic contention based protocol. It is having an hidden terminal and broadcast storm problem. Okay, throughput is not much more. There is a sender as well as data redundancy because of an hidden terminal problem and the collision. That can be, and it is continuous. Each and every node has to listen continuous for the incoming packets or image.
Fine. But TMAC, does it not require time synchronization?
TMAC requires a time synchronization, definitely.
So how
There
do
is
you-
one time called as an TA field. Again, it is based on the RTS CTS. Okay,
RTS CTS.
for the handshaking purpose.
RTS CTS is there is no RTS CTS in time synchronized protocol.
Yeah, basically in TMAC there is it is based on RTS CTS and the TA period.
What period?
TA, that is a frame and active time period. Up to what particular time span the node should be active, and what should be the time wherein that node can be in sleep position.
So, is the only difference between S2 torrent and deluge the fact that you are using TMAC versus CSMA?
Yeah, that is one of the design factor.
That is one difference.
Yeah.
What other difference is there?
Yeah, another difference is if you concern about the scope selection, then although suppose in the field say there are n number of nodes, or for example we consider there are 500 nodes, okay, and if I want to disseminate any image, so every time that deluge disseminate to all 500 nodes. So there is no scope selection. I cannot select a particular nodes for the selection purpose, for the
How do you
dissemination.
select scope?
By setting the attributes. That provision has been applicable in the S2 torrent. We define the node ID and group ID, and group wise we have assigned the role. So accordingly we can select any group, set the attribute, and on that attribute we can choose the nodes for the. So unnecessary many times, although that nodes are not interested to update, still it is updated in the deluge.
It is once the code comes, you can choose not to update, na?
Once the code comes,
You can choose not to update in deluge.
no, basically when image is disseminated, it is flood type protocol, no
How
sir?
is the node selection helping in efficiency?
Yeah, it is directly concerned with the energy constant. That Tmac and selection is unnecessary. Why to engage all the nodes? If I say something to only 2-3 persons, okay, other can do their own work. So why to disturb them every time? If I am disseminating, everyone has to taken care of mine. Why it should be? So that particular thing can be possible through the selection process. See, I can assign different role. Like if I say in a field, if there are sensors which are sensing the physical parameters, say temperature suppose. Okay,
That
so
again doesn't have, okay, that is just a if condition you are applying at some level. Okay, what is the protocol level difference? Is there any protocol level difference?
sir, to be elaborated for not getting the question exactly. In protocol sense means what?
Do you have a, you mentioned so many metrics on which S2 torrent is performing better. Why is it performing better? What feature of its design is making it perform better?
That we are discussing throughout the presentation. Sir.
I could not follow. You are not
So
making a
these are-
connection between the design idea and the performance benefit of that idea.
But still there is a question mark on the real-time test bed. So basically all these architectures, they are actually work in the field. They have tested over the field for the real time. But there was a big question for me, how to evaluate the design protocol. Okay, that's why every time I had taken the observation for deluge model and then S2 torrent. I modified each design factor and then taken parallelly both observations. So that gives the results.
I cannot follow anything. I cannot understand what is the protocol difference between deluge and your proposed system. You are using an underlying MAC which is different.
Yeah.
Okay, so that is somewhat independent of the transport mechanism itself.
Yes.
Reprogramming is a protocol which is independent of the underlying MAC protocol.
Yeah, but while choosing channel and
Deluge does
as
not
it is a
mandate-
multi-hop, so
Huh?
there must be a MAC. There might be a role of a MAC. If it is a multi-hop.
Yeah, but I mean, it is not a feature of deluge. It is like comparing
Sir, it is a complete architecture.
It's like
it's a
comparing
complete
TCP
framework.
running over an optical link and TCP running over a slow modem.
Basically, we are not considered TCP, it is UDP based.
I am just giving an example. Just like that, the deluge is a transport layer mechanism which is running on top of a certain MAC layer mechanism.
Right. It is a routing agent, sir, nothing. It is a routing agent. So moreover, you can say it can work on the network layer rather than the transport layer.
What is working on the network layer?
That it is a routing agent through and this reprogramming architecture.
Whatever it is, at the protocol level, what is the difference? I am not able to follow.
Sir, in what sense?
Protocol defines certain messages and certain actions to be taken based on those messages. Okay, deluge define certain message types using which it achieves reliable transfer of code required for reprogramming. Okay. Are you using the same set of messages, different set of messages? Are you defining new actions to be taken based on some messages? I mean, those are the things which constitute
See, whatever scenario I considered, it is same for both protocols. Every scenario is same, but tested for both the protocols. So it has just added the features and update the existing one.
Which feature have you changed or modified?
So I provided the selection support, attribute based reprogramming.
Fine,
Then we have provided the adaptive slipping rather than the listening mode only. We have provided the heterogeneous environment rather than the homogeneous.
Explain that a little bit more. What is adaptive sleeping as opposed to listening?
Sir, in that listening mode, so every node must be alert for the incoming packets. What particular image is coming, so it is always in the listening mode. It cannot be sleep or take rest to save an energy. So it is an prominent constant in the sensor network that must be saved. So there must be some provision to save that energy. So we try to provide the adaptive sleeping, which is not possible if I use the CSMA.
Okay, so
that's why I try to use the another
TMAC. Okay, I think the benefits you are getting purely because you are using TMAC as opposed to CSMA.
Yeah, mostly.
Okay, but that's not a protocol. It's just a setting difference. I mean,
but whatever they are doing in every research, if you look, so there are a difference of it means they are doing some optimization by using the various or varying the design factors. So if you will see the comparable design factors in the proposed architecture, so the base suitable design factors have been considered over there. But ultimately all these architectures, they are based on the real test bed, sir. That is the problem. And
based on real test bed is a problem.
This particular protocol is need to be tested on the real base. Only then and then only whatever simulation result we have got, whether the same result will get in the real test bed or not.
Is your contribution that you evaluated on a simulation as opposed to a real test bed?
No.
What is the contribution?
Contribution is to design a new dissemination protocol.
It is not a new dissemination protocol.
It is modified.
No, I think you are using the same dissemination protocol on top of a different MAC. That is not a new dissemination protocol.
But if we modify the different features, so if you forget about the MAC.
What is the feature of deluge that you have modified? I am not able to follow that.
So please give me suggestions for the further research, so that I will take some directions.
Okay, so my feedback is that you need to think hard about what exactly is new in the protocol design. See,
where should be the focus?
Deluge is the transport layer and CSMA is in the MAC layer.
Right.
Okay. So you are evaluating deluge on top of CSMA and comparing it with deluge on top of another MAC.
Another MAC.
So you have not designed a new protocol. You just swapped the MAC protocol underneath the transport protocol. Deluge remains the same. And it is no surprise that if you replace CSMA with TMAC, you are going to get a lot of benefits on a lot of features, because
see, that are only concerned with the energy constant. Whatever
so you
we
are
are
going to
getting
get those benefits because you have made an assumption of time synchronization, which is in practice difficult to achieve.
Then why researchers are not designed by using TMAC till date?
That's what I am saying. That's
a question mark.
The answer to the question is time synchronization in practice is not easy to achieve. Hence they have used CSMA.
But it's not a contribution that we achieve that by using T-Mac.
No, you have assumed that time synchronization is possible.
Okay.
No, protocol level there is, I'm not.
What should be the another focus, sir?
I mean, if you are claiming to have designed a new protocol, there must be a new design, which means, you know, you say this is how file transfer happens from one node to multiple other nodes. What is the, you need to construct a toy example. This is how the flow happens.
See, 0 to 100% is not, we can say it is a modified version. Can we say?
I'm not sure it is modified. It is just,
Okay.
you are just using the same transport protocol on top, and using another MAC protocol underneath. Okay, we can
Any other
talk more
question?
offline.
Thank you, sir.